Good morning or good afternoon, depending on where you are from, and welcome to today's webinar, Key Findings from the Stella McCartney LCA study, a study of man-made cellulose fiber from 10 sources. Before we get started, I'd like to go over a few housekeeping items. First of all, my name is Karen Righthand. I'm the Director of Sales and Marketing at SCSglobal Services. I wanted to let you know that this webinar is being recorded, and we will send out the link to the recording in the next day or two. You will also have the opportunity to submit text questions to today's presentation by typing your questions into the questions pane of the control panel that's located in the upper right corner of your screen. So you may send in your questions at any time during the presentation. While you're thinking about a question, just feel free to type it into that pane, and we will collect these and address them during the Q&A session at the end of the presentation, depending on how much time we have left. Now I would like to introduce Tobias Schultz. Tobias is the Director of Research and Development for SCS. He is one of SCS's premier LCA experts and managed the completion of the Stella McCartney LCA. We also have Aditi Suresh, LCA practitioner at the SCS, who was the LCA practitioner of the study. She will be available to answer questions during the Q&A. And last but not least, I'd like to introduce Amanda Carr, Director of Strategic Initiatives at Canopy. She will take a moment to put the SCS study in context with the Canopy Style Initiative at the end of the presentation. Now I'd like to hand it off to Tobias.
Great. Hello, everyone. This is Tobias, and thanks for joining us today. I look forward to getting into this topic with everyone. And the topic is, as Karen said, the life cycle assessment of man-made cellulose fiber from 10 sources. That was SCS completed, commissioned by Stella McCartney. So, what is SCSglobal Services? Many of you know who we are and may even have worked with us previously, but I'll just give a short intro in case you don't know who we are. We are an environmental and sustainability certification and consulting company. We operate in 3 major areas: natural resources, food and agriculture, and environmental certification services. And within those different areas, we have over 90 different certifications and consulting services. We've been around for going on 35 years now. We're a unique company in that we're focused solely on sustainability-related certifications and consulting. So it's the only thing we do. We also have 25 years in the practice of life cycle assessment, and we have a staff which has decades of total LCA experience. So this has always been a very important part of what SCS has done over the time that we've been operating. So getting into the study now, and the key research question that this study answers is, what's the environmental performance of viscose fiber from different sources? So just a few high-level points that I'll get into deeper throughout the rest of the presentation. The study compares 10 sources of man-made cellulose fiber using life cycle assessment. So there's different terms, but they all refer to the same type of fiber here. I mean, viscose, rayon. Man-made cellulose fiber is the term that was used in the LCA because we have a couple of innovative materials that aren't strictly considered viscose that we also included. So it's a more inclusive term. The study, as I said, it includes these innovative technologies, but it also compares wood-based viscose from several different sources with innovative new materials. It also includes critical new environmental issues like ecosystem impacts and certain climate pollutants affecting climate change, such as black carbon, that haven't been included in previous LCA studies. It also uses detailed primary data across all of the scenarios. For all of these reasons, this is really the broadest and deepest LCA yet completed for this fiber, both in terms of the number of different impact categories that it considers and the level of depth of analysis it went into for each of those impact categories. So the scope of this LCA, it was cradle to gate, and all of the values were assessed per 1,000 tons of man-made cellulose fiber. That's the acronym there, MMCF. It's a little easier to say than man-made cellulose fiber. And it considers the first three main production steps in man-made cellulose fiber. So wood or agricultural harvest being the first, depending on whether it's a wood-based material or one from an agricultural product. These different materials are then transported to dissolving pulp mills. Dissolving pulp is then transported to fiber mills. And then after that, fiber is dyed, spun into yarns, and all the different steps involved in producing apparel, transport to market, use of the fibers, and end of life. Because it is an LCA study, it of course also included inputs like chemicals, land, fuels to these different processes, as well as outputs like air emissions of CO2, greenhouse gases, particulate matters, and etc. In the scope of the study included all the stages involved of production up until fiber, and then also all of these inputs and outputs associated with every step. So it was a cradle-to-gate LCA that included man-made cellulose fiber. What are these 10 fiber sources from global supply chains? There's a wide diversity of different sourcing and material, and each one is very specific, not just to a material class, but to the specific regions of production. And for all of these scenarios, even the fiber mill was not in the same place as the dissolving pulp mill. So everyone represents a global supply chain. So it included German production from Swedish forest pulp, Asian production from Canadian forest pulp, Chinese fiber production from Indonesian pulp, both from rainforests and from plantations are two scenarios, German production from recycled pulp, Chinese production from Chinese bamboo pulp, Chinese fiber production from Indian cotton linter pulped in China, Chinese production from South African pulp, Austrian production from a mix of South African and Austrian forest pulp, and then finally Belgian flax production. So if you look at the entire map of the different supply chain across the entire world, the little triangles are dissolving pulp mills, the yellow squares are viscose fiber mills. You can see that it really is truly a global study looking at North America, Asia, Europe, Africa, and other parts of the world. And each one, because it is so specific, it's really a key point is that the sourcing really matters quite dramatically. You can't just say viscose versus cotton versus bamboo. It really comes down to what are the sources, and this analysis looked at very specific sourcing supply chains for these different scenarios. Methodology used in the Stella McCartney LCA. I'll spend a few slides talking about that. This is a complete LCA methodology. It considers all of the environmental performance issues relevant to man-made cellulose fiber. So it draws from a list of roughly 30 impact categories, and from that 30 focuses on the handful that are actually relevant to production for these different supply chains. And in the end, it comes to about 12 impact categories were relevant and considered. So this excludes those that aren't relevant and focuses just on those that are important. It's accurate. It uses metrics that were developed with the world's leading scientists on issues such as climate change and ecosystem impacts. Practical, of the, I think, roughly 80 or 100 total fiber and pulp mills in the world, in this study we were able to focus down the data collection to just a handful while still capturing the key areas of production. So really, using a sampling approach, reduced the data collection needs by over 80%. Standardized, I'll talk some about the standards that the study was based on in the next couple of slides. And credible. During the standards development process and the peer review, we had a multi-stakeholder review process of the methodology and the study itself. So it really is credible among stakeholders, as diverse as academics with experts in ecosystem impacts, NGOs, and we were very happy to have Canopy serve on the peer review panel, but also LCA experts from leading universities and institutions as well. What were the standards used in the study? So it was based on a US standard, the LEO S002, which is a draft American national standard under the ANSI process, the American National Standards Institute. That standard is in a final draft form. The same methodology was also proposed for as a revision to the ISO 1444 standard in 2015. So there's been some discussion about its inclusion at the international level as well. The study also drew on a product category rule for roundwood. This was developed by a set of NGOs. SCS was the chair of the product category rule development group, which was commissioned by the Environmental Paper Network. That PCR was put out earlier this year. And this PCR had very, very highly detailed methods for how to evaluate ecosystem impacts within forests and carbon storage impacts. And itself had a very diverse multi-stakeholder group, experts from the University of Southern California, NGOs like from the Sierra Club. It had a very diverse and expert stakeholder group that developed this method as well. In-depth peer review, I alluded to this, but we had a set of leading experts that contributed to this study from PwC, from the University of Utrecht, from the Smithsonian Tropical Research Institute, and from Canopy. So really, thought leaders all contributed to this study. Some of the primary data sources used throughout the study, we were very pleased to be able to use primary data for all the key processes across the entire study. This included for all of the ecosystem impacts that were evaluated, we had access to 100% site-specific primary data for all of the scenarios. For dissolving pulp production, we were similarly able to use 100% primary data. So this is from 3 mills contributing data, and then 7 of the mills, we had primary data from the database provided by RISI. For fiber production, we also had 100% primary data, and similar to that, we had 3 mills contributing, and then for 7 of the mills, we had data from a research group, the CCF group, that was specific to the mills that we assessed. As I mentioned, there were 12 impact categories that we evaluated in a detailed analysis, and so the study includes results for all 10 scenarios across all of these impact categories. I won't get into the depth here, but this just shows a highlight chart looking at the different scenarios and impact categories. As you can see, there really is just a wealth of information contained in this study. So getting into discussion of the ecosystem impacts, because this was one of the most groundbreaking pieces of the study, and certainly one that we were very excited to apply to work through on such a global scale. And this is the first LCA that includes a detailed scientific evaluation of ecosystem impacts for man-made cellulose fiber. Now, this is very important because previous LCAs, which have left them out, really can't tell the difference between what might be highly impactful forestry, like you see on the left-hand side, from responsible forestry, like you might see on the right-hand side. So this LCA ensures that a picture like on the left does not look like a picture like you have on the right. And I'll talk about some of the data sources we use to get to the bottom of that on the next few slides. This is really important because it really reflects the on-the-ground impacts for deforestation and forest degradation in certain hotspots around the world, and I'll talk about a couple of examples of that, Indonesia and Canopy as I go through, or sorry, Canada, as I go through the next few slides. Analyzing effects within WWF ecoregions. So this is a critical piece of this ecosystem impact evaluation. And the WWF has defined a global map for what are called ecoregions, so distinguishing different types of forests and grasslands and other types of ecosystems around the entire world. And so the study focused on impacts within these different ecoregions. So it was highly specific and tailored to the different nuances of forests in, for example, Sweden versus Austria versus Canada, and even looking at the different nuances of in South Africa, it was actually eucalyptus plantation planted in grassland regions. So a very different type of ecoregion with its own unique impact profile, because in large part because of the region. The whole basis of the ecosystem evaluation is the comparison of the harvested areas where wood and agricultural products are produced to make pulp and eventually fiber, and comparing the ecosystem and forest conditions in those harvested areas to undisturbed forests in the region. And the roundwood product category rule that we used had a very detailed and sophisticated definition of undisturbed forests. Essentially, it only requires forests have to have experienced no disturbance for over 80 years and be within a certain region of the harvested area. So for example, if you look in this map of Canada and you zoom in to forests here in British Columbia, comparison that we looked at was an undisturbed area in the red next to an adjacent harvested area in the yellow. And so we're able to use mapping and specific data from the Canada Forest Inventory to look at the conditions in the undisturbed forest and compare it to the forests that are actually undergoing harvest. Now, how do we look at that analysis? That seems like it might be pretty challenging, and it certainly is not trivial to actually access on-the-ground site-specific data on forest conditions for all these different scenarios. And something that we considered as a major breakthrough in this study is just the number of newly available global data sources on ecosystem impacts. And really, this is just big data coming home to be very useful in this LCA process here. A number of these databases only came out in the last 3 or 4 years. So some of these data sources, the report contains a whole wealth of them. For example, in Indonesia, we had site-specific satellite data from Eyes on the Forest, which was developed by WWF Indonesia, so that I have very detailed maps of primary forests in the region where the pulp mills are that we looked at. And in fact, we were able to even overlay the harvested areas over the forests. That's what you can see in this graphic here of over time as the forests have been cleared in this part of Indonesia. This is reflected in our study. We also have extremely detailed on-the-ground forest condition data from the Swedish, Canadian, and Austrian forest services. So just as an example of the level of data granularity we were able to get in these regions, this is an excerpt from Canada, forests in Canada, and so we were able to get down to very specific metrics like the percent of total species that are black spruce versus eastern white cedar versus sugar maple, and then very sophisticated forest inventory metrics that are commonly used in forestry practice, like stem wood biomass, coarse woody debris volume. And we're able to get to very detailed measures of each of these. And so you start to see patterns emerge when you look at this data, both in terms of the species that are found in harvested areas versus undisturbed, as well as the amount of carbon stored in undisturbed forests, which is always universally dramatically higher in undisturbed forests versus harvested ones. Another critical part of this study is going beyond just an analysis of forest conditions to actually look at the threatened species that are affected within these different forests. So this goes beyond general measures of biodiversity to actually focus on the species of most critical concern in these regions, and those are the species that are threatened or endangered of becoming extinct. And we drew on global data sources from the IUCN Red List, and then within each of the countries we also looked at specific government and local stakeholder developed lists of threatened species. And it turns out there's a huge amount of information on threatened species on a global basis that we were able to use. Now, we had a very sophisticated and detailed way for species that were included. We just didn't blanket include all threatened species. The species had to be present in the harvested area or the fiber basket of the different dissolving pulp mills. And harvesting impacts had to negatively affect populations or regional habitats. So if you're harvesting a forest in a region, a species that inhabits grassland nearby might not actually be negatively affected by forest harvest, whereas a species that depends on primary forest is going to be in big trouble in that same situation. So just as an example of one of the species that was affected, a pretty famous example is the Sumatran orangutan. And so this is just a snapshot of the IUCN Red List of Threatened Species reports on this species in Indonesia. This IUCN report actually includes a range map of the species, so you can see on the screen Sumatra, and in the orange is where this orangutan currently exists and is extant. And if you look at where the dissolving pulp mill it's right smack dab in the middle of the range of this orangutan. So clearly there's implications for orangutan habitat and populations from operating in this region. And in fact, if you look at the data that this database provides, it actually calls out the different threats that are affecting orangutans. So I'll just read this out. Sumatran orangutan survival is seriously threatened by habitat loss and fragmentation. Forests continue to be cleared at the large scale. Palm oil plantations are a key driver here, but also logging for timber does remain a threat, as does the creation of new logging roads, which serves to further fragment populations. So in this area, you have forestry, you have a species in those forests, and the species is negatively affected because of harvesting that's going on. And so using these different data sources, we were able to compile a whole inventory of the different threatened species affected in each region. And so, for example, using some of the other lists in Canada, also the caribou was included using the same rubric methodology, as were many other species, but this is just another quick example. Now, when you wrap up all these tools and the outcome of these ecosystem impact methodology, they really do provide an unprecedented transparency into ecosystem impacts of fiber from these very different sources. So this chart is pulled directly from the report. The green bars show the what forest disturbance results for each of the 10 scenarios. The scarlet and pink bars show the key species that are affected in each of the scenarios. So I won't go into the extreme detail, but things that do stand out are the two scenarios that perform the most poorly. Indonesian production from rainforest pulp, so actually harvesting of tropical hardwoods from within intact forests, not surprisingly, has by far the largest impact results, but the second largest is actually extraction from forests in Canada from various reasons, which I will talk about. Picture is slightly different for species, and slightly different just in the sense that Indonesia is dramatically and far and above worse than any other scenario in terms of the number of species affected. And that's, again, not too surprising what we know about what is going on in Indonesia. So that's what these big tall bars are on the right. So this really reflects deforestation in Indonesia, which is a well-known problem, and forests there. There's a lot of concern that primary rainforests might be completely gone there just in the next 10 or 15 years at the rate of harvest that are going on. It also reflects the multiple threats to the boreal forest in Canada. So these forests are really being impacted by a number of things. So accelerating global warming, for one. So millions of hectares of forest fires are occurring each year. Probably lesser known, but also very important, are pine bark beetle infestations. They can move into these forests now because they're not as cold, and that's actually affecting millions more hectares of forests every year. Beyond anthropogenic global warming, you also have industrial forest conversion on a large scale. So this is just a quick analysis of the different major contributors. I mean, you have agriculture, you have oil and gas. Oil sands is a big presence up there. Forestry, that's the white bar, that's one of the top 3 contributors to forest conversion in the boreal from anthropogenic purposes. And of course, beyond straight forest conversion, you also have pretty intense forest harvesting itself across nearly 1 million hectares per year. And this is just a chart showing forest harvest over time in the boreal, and they've been increasing over the past 5 years or so. And these LCA results really do reflect these big impacts in Canada and Indonesia, and that's part of the reason why those two scenarios stand out as having such impacts for on ecosystems. Another very important aspect of the ecosystem impacts is their effect on biogenic carbon storage, and this is another key part of the study that was factored in. So what you have here is the results on climate change for these different scenarios, both looking at the warming and competing cooling influences on the right, and then also the net effect on the results. And these top bars here, these cross-hatch bars, these are actually the biogenic carbon storage losses for these different scenarios. And so, for example, for scenario 2 for Canada, you have 9.5 tons of CO2 out of a total, or with other pollutants contributing 11. And actually, the biogenic carbon storage losses in Indonesia essentially double the climate change warming impact for Indonesia. So very significant impacts from these two scenarios because of these ecosystem impacts on the climate change indicator. And so when you wrap this all up, these two scenarios, Indonesia and Canada, also have the worst climate change, global warming performance, and that's really driven primarily because of these biogenic carbon storage effects, which are more than twice as high as for any other scenario. Another key part of this study is that beyond including the biogenic carbon storage losses, it also includes all climate pollutants. So for example, the study included black carbon, which might be the most important climate pollutant you haven't heard of before. So black carbon is widely regarded by climate scientists as being the second most important climate pollutant after CO2 causing global warming. It's well studied by climate scientists. This is a satellite map from NASA showing black carbon concentrations all around the world. And black carbon and another key short-lived climate pollutant, ozone, tropospheric ozone, ended up being very important for this study. Black carbon accounted for something like 15 or 25% of global warming impacts for all scenarios. Tropospheric ozone accounted for 10 to 28%, depending on the scenario. So both very significant in their effect on the overall climate change performance of the different scenarios. Now this is also very critical to include these two pollutants, black carbon and tropospheric ozone, because the finding by the United Nations Environment Program and World Meteorological Organization is that these two pollutants must be mitigated along with CO2 in order to achieve the Paris Agreement goals. So we don't have even a hope of maintaining the 2°C temperatures in the world without mitigating these two pollutants very aggressively. So this LCA is also very important in the sense that no previous fiber LCA has included these two critical short-lived climate pollutants. What are the big sources of these two pollutants in the man-made cellulose fiber supply chain? So black carbon, this is mostly associated with Asian sources of production. So this is from burning of fossil fuels and boilers during the dissolving pulp production, transportation using diesel fuel, and then also upstream energy generation. So things like the electricity used in the different mills and different life cycle stages also had black carbon emissions associated with it. Tropospheric ozone, which is formed from nitrogen oxides or NOx. Those major sources include mainly operations at dissolving pulp mills and fiber mills, but also similarly upstream energy generation as well. So really the industrial side of these supply chains is contributing to these pollutants. The study also broke new ground by including a regionalized analysis of smog impacts. This is very significant for some of the scenarios. This is a video showing a city in Asia, and that's actually smog. That's not fog, and that's just a typical day in some of the regions of production that we looked at, where you have particulate matter concentrations, going 200 or 300 micrograms per cubic meter, whereas in places like the U.S. and even Los Angeles, which has notoriously the worst air pollution in the United States, isn't even 10% of that. The worst day in LA you'd ever find is more like 20. So in these regions, it's quite significantly worse. And by factoring in the regionalized smog impacts, production in smog hotspots like China and India led to as much as 100-fold higher LCA result for these specific impact categories. So if you look at the chart of the particulate matter, the PM2.5 impacts across the 10 scenarios, you kind of see a bifurcation between several scenarios with really low impact levels and then bar charts that are much, much, much higher. All of those essentially have supply chains involved in Asia, where there really is just such bad smog problems. So in conclusion, what are the key takeaways of this study? One is that it really is man-made cellulose fiber versus man-made cellulose fiber. It's not sufficient to say viscose from wood is better than fiber from cotton or fiber from bamboo or from recycled. Even in the study, viscose that is essentially identical from different sources of wood in different parts of the world had really dramatically different impact profiles. And we even found, for example, in Indonesia, we looked at eucalyptus plantations versus rainforests, and while neither look good, there's a big difference in the impact profile even for fiber sourced from places that are adjacent in Indonesia. So really, you can't even just say based on the region of production. You really have to get down to the on the ground, what's happening in the forests and what different harvest practices are being undertaken. And it really has to get down to the supply chain level to be able to tell useful information. Another takeaway is there was no unambiguously preferable fiber source. There's no home run where one fiber source was better than any other fiber source. Everything had trade-offs. That being said, if you look on a net basis overall, the flax and recycled pulp sources of fiber had the most environmental benefits overall. So these were two of the innovative technologies that are being developed and are being scaled up now and appear to have very good, compelling environmental performance benefits. There were also a number of problem sources with heavy footprints. I mean, I talked extensively about Indonesian fiber forestry, which is just a worldwide well-known problem, as well are these smog problems in different parts of Asia. But you have much of these different scenarios, particularly those associated with Asian production, having these heavy footprints associated with them. And with that, we can go to the questions and answers.
Thank you, Tobias. We have a few minutes for questions and answers. As a reminder, please feel free to continue to submit questions in the question pane in your attendee control panel. And while you're submitting questions, we're going to hear from Amanda Carr at Canopy, and she will add some context about the study and its role in forwarding their Canopy Style initiative. Amanda?
Yeah, thank you so much for allowing Canopy to just take a moment and reflect on sort of the importance of this study as it relates to our collaboration with companies. I think first and foremost, a really big thank you to the SCS team, Aditi and Tobias, and others who worked on the study, as well as to Stella McCartney for commissioning the study. And my colleague, Neva Murtha, who's many of you know, but she was the chair of the LCA advisory panel and put a lot of time and effort into coordinating folks. So when we began our work at Canopy Style on the Canopy Style initiative 4 years ago, viscose and how it was made, what it was made from, it wasn't something that was particularly well understood. And because we know that fabrics and the clothing supply chain and the global trade systems that are part of that are very complex, we're really excited because we think this LCA helps provide and create clarity. Just a little bit of reflection. For Canopy, the exercise of being on a review panel for an LCA isn't something we take on lightly. We don't, our giving policy doesn't allow us to take compensation for our role in LCAs. And we're also mindful that a lot of LCAs in the world don't yet address things like species loss, land use, biogenic carbon. So I just want to acknowledge that SCS was up to that challenge to produce a cutting-edge LCA and to thank them for that. Likewise, we're always a bit nervous to engage in these kind of exercises because new research, evaluation, studies, you know, they have the potential to blow our assumptions and the investments in how we're forwarding forest protection, and also how we're working on more sustainable supply chains. They have the potential to really blow some of those assumptions and investments out of the water. Because while Canopy's mandate is to protect the world's forests and the species and climate that depend on those forests, we're always mindful of not trading in one environmental issue for another. And so LCAs have the potential and always do bring that guiding principle home for Canopy and all of our work. So I think Tobias mentioned, but we also know that we only have one piece of the puzzle, so it was wonderful to have PricewaterhouseCoopers on the panel, bringing their expertise on environmental profit and loss within clothing brands into the mix, to have the tropical forest expert from the Smithsonian, and also a panel member who knew viscose processing so very well. If I sort of look at the LCA and how it relates to Canopy's work, it does reinforce the strategic direction of the Canopy Style Initiative, the opportunity to reduce global impacts for brands and producers who are acting on their policies. But the LCA also demonstrates it's not simply about substituting trees with something else, I think, which is a really important takeaway. So more specifically, when we look at the scenarios in the BOREAL, in Indonesia, and in the plantations that have been converted, obviously the LCA performs weakly for those scenarios in many of the impact categories, and it reinforces the need to source from ancient endangered forests. But on the flip side of that, scenarios 10 and 5 reflect those emerging options for sourcing, for processing differently to lower our impacts overall. So really reinforcing that when we look at innovative fibers, the scenarios that include data from RenewCell and Kralar and what they're doing are an important and key strategy of the Canopy Style Initiative, and it reinforces that tenet that is included in the policies of the 100 brands, retailers and designers who have policies with Canopy, and also with the viscose producers who have policies and are part of the Canopy Style Initiative and represent 70% of the entire global production of fabric types. So in terms of how brands and producers can use this LCA, if you're part of the Canopy Style Initiative and have a policy in place, it's information that I think reinforces the path we're all on together is the right one. And for others, it kind of serves as key scientific findings to justify the need to act, to reinforce the value proposition of joining a collaborative approach to tackling forest product impacts and putting a policy in place with Canopy, and just doing that in a way so that we're all sending consistent signals down through the supply chains and supporting our suppliers in reducing the impacts of forest-based products. So a big thank you to everyone for joining the call, taking the time to absorb the findings, considering your company's next steps, and the offer that Canopy and the team here are available to support your forest policy development and also its implementation. So thank you.
Great, thanks, Amanda. And we have had a number of questions come in, so I'll just read out loud the questions and then give an answer to them. So one question that's an interesting one is how is black carbon defined? What is black carbon? So this black carbon was this very critical short-lived climate pollutant that we included in the study, ended up being a big driver of climate change performance for the different scenarios. So black carbon is very clearly defined by climate scientists. It's a form of particulate carbon or particulate matter that is elemental carbon, and it literally is just black colored. Because it's black, it absorbs sunlight as it comes into the atmosphere or is reflected from the surface. So you can just think of black soot in the air, and it literally just absorbs the sunlight and warms things up directly. When it's emitted in northern latitudes, or even just in wintertime, in not so northern latitudes, when it deposits on snow, it'll darken the snow and cause the same effect of sunlight absorption. And it has a very potent global warming effect with a global warming potential of over 3,000 and then as high as 5,000 when it's emitted in some regions with lots of snow. So clearly a really important thing to include. So next question. I've actually had a couple questions pertaining to will the LCI data be made available in LCA database. And we don't have plans to include it in EcoInvent or anything like that. However, we are in the development. We're developing our own LCA database that would include all this different LCA data so that it can be more widely shareable. We've just received a lot of requests for more detailed on the data, and so we are in the process of putting that together. So if you're interested in receiving that LCA data and learning about that LCA database once it's launched, just shoot me an email. My email is on the screen right there. So next question, does the SAC, that's the Sustainable Apparel Coalition, does their material sustainability index include this data? This is a good question. We are looking into this data in the MSI, as it's called. Right now, the MSI doesn't include some of the most critical issues like the ecosystem impacts, black carbon emissions, or impact categories like ocean acidification. So we are hoping that they'll agree to provide transparency on all these other impact categories so that the proper performance differentials of the scenarios are accurately reflected. So it's not there now. We're looking into what we can do to integrate this data. Let's see. Sorry, there's just a number of questions coming through. So here's a question that I think Amanda spoke to it, but got reiterated, and I think it's an interesting one to talk about. And the question is, what are the major lessons about improving production processes? And so really, we've thought about this a lot, and there's a couple things that industry players are already doing and could do that would be very beneficial. So for one thing, avoiding fiber from hotspots like Indonesia and Canada is really good, and that's, I think, what's going on with the Canopy Style Initiative. So that's a very good thing that many players are already doing. Another low-hanging fruit that this study really points out and emphasizes is to work within supply chains to reduce black carbon emissions. And this actually has a twin benefit, both through reducing climate change, but also potentially smog in different regions, because black carbon is also a contributor to smog. Reducing black carbon is actually generally very inexpensive to address using basic types of scrubbing technologies. You can, for example, retrofit diesel trucks with particulate filters, and the same thing with mills. So it's actually a quite cost-effective thing to do across supply chains. So there's something that even a global brand could do, just require adoption of black carbon mitigating technologies throughout the supply chain. So a couple questions about the ISO standards, international standards this study is based on. I mean, in addition to the American standard I mentioned, it does conform to ISO 1440 and 1444, which are the cardinal most often used standards for LCA. Okay, so here's a very interesting question. I'll just read it out loud. Knowing now that the on-site forestry management matters so incredibly much to a material's environmental impact, how does the global nature of trade influence the material's impact? Essentially, if a forest is managed well in South Africa, is it environmentally responsible to produce the staple fiber in Europe versus locally in South Africa? So this is a great question. If you look at across these different scenarios, it really is, what you really see is that the on-site forestry management drives the impact for certain impact categories. So if you're looking at ecosystem impacts versus species, that's driven entirely by on-the-ground impacts. And part of the nature of that too is that the impacts are occurring in different regions. So there's reasons that they're qualitatively different. So forests in Sweden are not the same as actually it's grasslands in South Africa that were displaced. So I don't think it's a simple question that one is environmentally responsible to produce, Europe versus South Africa. I will say that in any region, it's possible to practice responsible forestry, so it's always possible to improve practices within certain regions. So, I mean, that's just a useful, I think, lesson that this study can drive towards, is pointing towards things that can be done to improve practices in regions where sourcing is occurring regardless. Okay. So here's a question on the impact category list. I noticed the study includes ocean acidification, which is caused by carbon dioxide emissions. Isn't that double counting with climate change? So actually, so I see Amanda. Did you want to make a comment, Amanda?
And sorry, I'm going to back us up a little bit. But I just wanted to also add that you know, when we look at forest management as a way to address impacts, in addition to that, you know, there are potentials for sort of land use planning solutions. So from Canopy's perspective, we would never say, you know, never ever buy from this region, because I think it's important that the economic drivers of deforestation also weigh in and create lasting solutions. So what we're looking for is conservation, scientifically based conservation planning. And once we've decided where we should be logging and where we shouldn't be logging, and then of course we're looking to sustainable forest management and FSC, Forest Stewardship Council certification as an indicator of that. So just something to think about when we think of scenario 2, for example. It's a mill in the Boreal that may convert to dissolving pulp. The company who owns it has put moratorium in place and is looking to forward conservation planning, as well as forest certification. So there are definite off-ramps that make the impacts reduce so significantly that those scenarios can come back on the table, as it were.
Great, thanks Amanda. Yeah. And so this question on ocean acidification, so the question is if ocean acidification, because it's caused by CO2 emissions, if that's double counting with global warming. So this is a question I've heard before, and actually carbon dioxide emissions, or carbon dioxide after it's emitted into the atmosphere from a power plant or a car, it actually does double duty on its impacts. It first causes global warming in the atmosphere, but then actually a very large fraction of that carbon dioxide, over like a quarter in the first year, is then absorbed into the oceans and increases their acidity. And this ocean acidification is already wreaking havoc on some marine ecosystems like coral reefs in the tropics. But the global warming and ocean acidification, they're caused by the same pollutant, but they're completely distinct impacts. If you could imagine a world where carbon dioxide didn't have a greenhouse effect, it would still actually lead to ocean acidification and vice versa. And so because it's an LCA, it's considered a serial impact category. And so, for example, you have multiple impact categories that treat a NOx emission, so ozone and particulate matter, and even potentially acidification. Just as that is the case for CO2, we treat these two different impact categories and impacts resulting from the emission. So the question is, what kind of recycled pulps have the least impact / help the most? So this study looked just at recycled pulp from one source, so it doesn't tell a broader analysis of looking at recycled pulps from different types of materials. It really is just focused on this. So we can't answer that question, I mean, with this study, because it is just scoped on the one production chain of German production of the fiber. And Aditi, could you comment on what materials were used to make that recycled pulp, just so it's clear to everyone?
Yeah, sure. So the materials in this mill that we considered were from textile clothing, particularly cotton and polyester clippings, I guess. And this is still a small plant, and they're scaling up. So what we have here is a pilot plant, but they're going to commercialize this in 2017, I guess.
Yeah. Thanks, Aditi. Let's see. So here's actually a couple questions about this. I'll read this question, but there's a couple similar to it. This study clearly includes a tremendous amount of detail. What would be your recommendation for anyone interested in building an LCA that sources pulp from different regions and situations? So I think one of our most exciting takeaways from this study was just the wealth of information you can get on both fiber production but also ecosystem impacts within these different regions. So, for example, a rule of thumb is for a dissolving pulp mill, and I shouldn't say this is a rule of thumb, this is just based on the economics of it, is that dissolving pulp mills won't be buying wood from very far away from their mill. It's just too expensive to ship far distances. So if you know where a dissolving pulp mill is, you essentially know where the forests are that are being harvested. So just even knowing that, you can start to define what species are going to be affected in the different regions. And if you're curious in actually trying that out yourself, if you just Google the IUCN Red List of Threatened Species, that'll help point you towards that. And more complex, but still publicly available, are the forest inventories in Canada, Sweden, and Austria. These are all free, and so you can really dig into those different databases and just get into very, very detailed information on forests in different regions. So it all starts from knowing where the forest is that you're looking at, and from that you can start to pull apart these different data sources. And the study, or the LCA report, I'm sorry, does talk about those data sources, so I encourage you to, it is available on our website. We don't have the link up here, but I think if you're interested in receiving the report or just learning more about the data that we used, we can get into more depth on the specifics. Just feel free to write me an email about that. And I think, Karen, do we have time for one more question, or are we going to have to conclude?
Sure. You can take one more, sure.
Okay. So, let's see. So here is a, hold on, sorry, there's so many questions coming through. Here's a question. Can you explain scenario 10's technology a bit more? This is the flax. Is the lack of a pulping process a cause for the low impact, or is it more about how the flax was sustainably harvested? I think in terms of on-the-ground performance, I think that you can just grow a whole lot of flax in relatively small area, so I think that's one driver. Is there anything else Aditi, is there anything else that stands out to you about scenario 10, about its technology or process?
Well, I would just like to add that the chemical processing that they do for flax is pretty minimal compared to other sources we look at. So it's and also the flax that they're processing, they are really short fibers, so they are byproducts of flax, and it's not entirely the flax fiber processing. So because they are byproducts, we have lower impacts assigned to the byproducts from these flax plants, which is why the impacts are lower.
Thanks, Aditi. And yeah, Karen, we can conclude. I know we're very close to the hour now.
Okay. Well, thank you, everyone. We want to be respectful of your time. If you have additional questions, please take down Tobias's email and or phone number. That's a Bay Area phone number, so that would be a +1 access code. And I also want to mention that you will be receiving a follow-up email in the next day or so with a link to the recording of today's webinar, so that if you want to share it with colleagues or listen to it again, you will be able to. And I also want to share that we will be starting a series of blogs on this topic, and the first in our series of blogs will be posted today, and it will be linked on our homepage. So if you just go to SCSglobalservices.com, you'll be able to click on the link and see the blog. So thank you to all of our participants for getting up early and for this very insightful topic. On behalf of SCS Global Services and our presenters, thank you for joining us all, and I hope you have a great rest of your day.